All right, last video for transformations here. We're going to take some parent functions, apply some transformations or identify some transformations, and then rewrite the function in an exponential equation. And then we'll also do some in logarithmic function form. So I'm going to zoom in on number 13 here. So number 13, your parent function is m of x is equal to 2 to the x. So let's keep track of that. Now, in transformational form, we've got this t of x. So if you look, like m of x is built into this problem, and we've adjusted it a little bit. So it's kind of like what we were doing is find the changes, and then let's identify them. So the first change there, that 0.5. So this is being multiplied times m of x. We're going to do a vertical, let's spell it right, a vertical compression by 0.5 or just 0.5. The reason it's compression is because that value is less than 1, and so it's compression. The last piece here is this x plus 3. This is inside the argument with x, so that is going to be a horizontal translation, and it's going to be opposite what you think it would be, so that's going to be to the left 3 units. All right, so those are the two transformations. Now we want to rewrite this and not use the m of x notation, but actually use 2 to the x. So our equation here is going to be t to the x, or t of x, is equal to 0.5. Now, where I would have m of x here, I want to use 2 to the x. So 2 to the x, that's going to be times. But keep in mind, we're adding 3 to x. So up here in the exponent position, I want to put a plus 3. All right, so we've got 0.5 times the whole function, and then the argument with x had the addition of 3 put in there. So there's my little equation, and there are my two transformations. That's it. I'm going to go ahead and do problem number 14 as well, and then we will, actually, I'll do number 14, and then I'm going to slide on down to do the other two more problems with logarithmic functions. So problem number 14, we have this original parent function. So m of x is equal to e to the x. Remember e, and I know it sounds weird, but e is a number in math class, just like I is a number or pi is a number. So it's just a common number that we use. All right, what have we changed? Well, we threw a negative in front and we are subtracting 1. Let me change colors on that one so I can make it pretty. All right, so first thing here, we've got this negative in front of m of x. That is going to be a reflection over the x-axis. All right, so that's the first thing. Second thing here, we've got this -1. It's outside of the argument, right? The parentheses close, then it says -1. So that's going to be a vertical translation, and that's going to be down 1 unit, or down 1. Now, what is the equation going to look like? Well, we're going to do t of x is equal to, we've got the negative. Now, m of x we're going to replace with e to the x. So e to the x. And then outside of that function, we're going to do a -1. So -1. And one thing you want to be careful about is, you'll notice, and I'm going to slide over so you can see both, if you want the plus 3 in the exponent, make it really obvious. If, in this case, the -1 is outside of that exponent and it's just being subtracted from the function, again, make it obvious what's the exponent versus what isn't. All right, so number 15, I'll go ahead and do on the key. If you have any questions, let me know. Let me go ahead and slide down to the logarithmic functions, and we will do, I'll do 16 and 17. All right, so number 16, let's go ahead and zoom in. First things first, we have m of x is equal to log of x. Remember, that's the same thing as log base 10 of x, but you get to be a little bit lazy and not bother writing the base 10 if that's what you got. So what's different? We've got a 3 here, and we have a +4 right there. So the 3 is going to be a vertical stretch by 3. And then the plus 4 at the end, that's outside of the function, so it's going to be a vertical translation. Let's go up 4 units. Okay, so it's positive 4, it's up 4. So what does the equation actually look like? Well, let's see here. If we have t of x is equal to 3, now m of x is going to get replaced with the logarithm. So 3 times log of x, and then outside of that you'd have a plus 4. Now if you want to get really specific, and this might not be a bad idea, put the x in parentheses so you know that this piece is done and then the plus 4 is separate. Okay, so that's not a bad idea to do there. All right, there's our equation. All right, one more problem, that's gonna be number 17. I'm gonna slide on over here, and this is m of x is equal to the natural log of x. Yes, I know it says ln and I just call it natural log. I know the order is backwards. It's just what it is. All right, so we've got a we have a transformation there with the negative in front of x, and we have a transformation here with a minus 1. So first things first, the negative that's sitting in front of x is going to be a reflection over the y-axis. All right, so that's going to be your horizontal translation. And then subtracting 1 at the end of the function is going to be a vertical translation. That's straightforward, so it's down 1 unit. And let's take a minute and actually write the equation here. So this is going to be t of x is equal to, now we want to write m of x here, but wherever x is, I want to throw a negative in front of it. So this is going to be the natural log of negative x, right? Put those parentheses around there to hold the negative in there, and then tack on a minus 1 at the end to account for that vertical translation. All right, we're going to go ahead and call this one the end of this video. I will pop up the other 2 answers in the whole key on Canvas. If you've got any questions or concerns, let me